prêt.
Donc en fait, je descends des millions d'années plus bas.
Potraga za izvanzemaljskim životom već stoljećima je jedna od velikih tema koje zanimaju znanstvenike. Od 60. godina 20. stoljeća znanstvenici su usredotočeni na najbliži nam planet Mars, te se nadaju da će na njemu otkriti život. Ako na crvenom planetu pronađemo život, imat ćemo prvi dokaz da je to raširen fenomen koji se ponavlja i drugdje u svemiru. U 50 godina misija na Mars došli smo do mnogo spoznaja o uvjetima nastanjivosti tog planeta i organizmima koji bi se ondje mogli pronaći. Tragovi vode, tragovi ugljika. To su posebno zanimljiva otkrića koja ohrabruju znanstvenike da nastave potragu za životom na Marsu. Cilj je poslati misiju sa specifičnim zadatkom da detektira život na Marsu. U igri je velik ulog. Naše dvije znanstvene novinarke, Emily i Marie-Pierre, imaju sastanak u pustinji Atakami. Ova pustinja na sjeveru Čilea, koja je velika gotovo kao Engleska, smatra se najsušnijim mjestom na zemlji. Međunarodna ekipa znanstvenika i inženjera iz SAD-a, Čilea, Španjolske i Francuske odlučila se na 2 tjedna smjestiti u srce ove pustinje radi jedne misije. Zbog geološkog sastava i iznimne suhoće, smatra se da su uvjeti u pustinji Atakami najbliži onomu što možemo naći na Marsu. Marie-Pierre i Emily sa znanstvenicima će testirati instrumente za detekciju života koji su izrađeni s posebnom namjenom, da ih pošalju na Mars.
Et ça y est, filles, on y est là. On est dans l'Atacama. On est dans l'endroit sur Terre le plus semblable à ce qu'on peut trouver sur Mars. Regarde, regarde, tu prends une photo là. Bam, tu compares à un cliché martien.
C'est pareil.
Qu'une différence.
Moi, j'aime ça, regarder en dessous des roches pour essayer de voir ce qui se cache. Tu sais, un gros lézard ou des petits insectes qui s'enfuient tout partout. Mais ici, on s'entend, aucune chance. Écoute, c'est tellement pas un environnement favorable à la vie. Et pourtant, il y a bel et bien des micro-organismes qui ont colonisé le désert d'Atacama. Ils portent très bien leur nom, extrémophiles. Ils aiment les conditions extrêmes.
Ouais, c'est pour ça qu'en fait, on se dit que si ici, dans le désert d'Atacama, on peut trouver des bactéries de l'extrême, on peut peut-être en trouver aussi sur la planète Mars. Du coup, les chercheurs, en fait, ils profitent de ce terrain-là, comme dans une sorte de laboratoire à ciel ouvert, pour préparer les futures missions martiennes de recherche de vie.
Ovi istraživači s raznih područja znanosti proizašli iz ekipa koje surađuju u misiji Icebreaker Life, ovdje u Atakami prvi su put zajedno. Cilj im je osmisliti misiju koja bi mogla konkurirati za program Discovery, američke svemirske agencije NASA. Natječu se za $600 milijuna koje je američka agencija namijenila za financiranje pobjedničke misije. Ta misija mogla bi poletjeti u potragu za životom na Marsu otprilike 2025. U ovoj operaciji jedan nasin istraživački centar NASA Ames surađuje s istraživačkim institutom SETI iz Kalifornije, sa španjolskim laboratorijem za egzobiologiju Solid i s konstruktorom robota Honeybee Roboticsom. U iduće 4 godine zajedno će razviti paletu instrumenata koji će možda jednog dana krenuti u misiju na Mars kako bi poslužili u potrazi za životom. U ovoj fazi znanstvenici nastoje utvrditi gdje bi točno trebalo tražiti život na Marsu. U tome će im poslužiti Marsov panda na zemlji, pustinja Atakama. Ondje će također testirati instrumente koje su zamislili u laboratoriju. Marie-Pierre i Emily dočekao je šef misije Brian Glass. Njih dvije ovih će nekoliko dana živjeti među znanstvenicima i s njima dijeliti svakodnevne izazove.
We are here at Yungay Station in the Atacama Desert in Chile. This station was originally established as an agricultural research station and has been mostly abandoned. So come on in. And you see sort of an atrium here between the two buildings with shade cloth to keep us a little bit cooler in the middle of the day with these chemistry, biology, robotics, communications, kitchen, and the central area for meals and working.
And where do people sleep?
People sleeping. That's not in here. There's not room for sleeping. But if we go outside, I'll show you. That's easy. This is the tent from our paramedic and our medical support. In here, we have stretchers and equipment and defibrillators if something happens. So we put our tents, these are personal tents in the shade of the trees. So you're going to have to put up your own personal tent. It looks like Mars in a very real sense. So I can't ask for anything more to find a place to test our technologies.
Zbog blizine andskih kordiljera i klimatskih uvjeta, Atakama je najsuša pustinja na svijetu. Vlaga je na ovom mjestu između 5 i 10%, ovisno o području. Za usporedbu, Sahara ima relativnu vlažnost veću od 20%. Ovo je mjesto s najmanje organskih tvari na zemlji. Pa ipak znanstvenici procjenjuju da je ovdje nekoć bilo jezero. Taj izvor života nestao je prije nekoliko milijuna godina, ali čini se da je ostavio tragove. Znanstvenici u tome vide priliku da prouče stanište u kojem su uvjeti granični za život na zemlji. Marie-Pierre i Emily sastaju se sa Alfonsom Davilom, stručnjakom za egzobiologiju koji proučava mogućnost izvanzemaljskog života. Često surađuje s NASA-om, naviknut je na ovaj teren i vodi ekipu znanstvenika koja će analizirati podzemlje pustinje Atakame.
To give you an idea of how dry the Atacama is, for example, it's even drier than the Sahara. That if you would take a bottle of water and put it in the Sahara Desert, 1 liter, at the end of that bottle would be filled with all the water that falls in the Sahara in 1 year. About 1 liter in 1 year. Then you take that bottle and you empty it on the ground. Whatever is left at the bottom, those few drops, is what falls in the Atacama in the same time span. It's extremely, extremely dry. And so life, of course, here is extremely, extremely difficult.
Mais comment ça se fait qu'il y a des arbres qui poussent?
Years ago, there was an experiment to grow plants in the desert. And some of the trees have managed to still survive. And as far as we can tell, they are probably not very happy, but still hanging there.
Mais est-ce qu'on pourrait dire que c'est l'endroit le plus hostile sur la Terre?
It is the driest place on Earth and the most hostile environment for life.
Mais alors, qu'est-ce que vous allez faire ici? C'est quoi les objectifs principaux de la mission?
Because the Atacama is so dry and it's been dry for so long, it's an excellent analog to Mars. It's an excellent place where we can learn things about Mars. For example, what happens to life when an environment becomes increasingly dry. And we can also do testing of instruments that we'll want to send to Mars to do science. And so this mission embraces these both concepts at the same time. We are here to do science and we're also here to test technology.
Dvije ekipe morat će na jednom roveru smjestiti bušilicu, ručicu za prijenos uzoraka, laboratorij za detektiranje znakova života i laboratorij za vlažne kemijske metode. Znanstvenici žele NASA pokazati tehničku izvedivost i znanstvenu vrijednost misije koja bi na Marsu tražila znakove života.
Alors ici, on a une belle vue. Ok. Ça c'est là. C'est quand même génial quand on y pense quoi. On va vivre juste au jour le jour le quotidien des chercheurs qui préparent à la quête de la vie sur Mars, ici dans l'Atacama.
Oui, puis c'est comme un deuxième épisode, en quelque sorte.
Ouais, c'est ça. En fait, la quête de la vie sur Mars, elle est vraiment pas nouvelle. En fait, elle a commencé il y a 40 ans avec l'envoi des sondes Vikings. En 1976, Viking 1, Viking 2 se posent à la surface de Mars. Et à l'époque, on est persuadé que si la vie existe sur Mars, elles vont les trouver. Mais là, c'est la douche froide.
Amère déception.
Pas la moindre trace de bactéries, pas la moindre trace de fossiles de bactéries. À ce moment-là, plus aucune sonde martienne dédiée à la quête de vie ne sera envoyée pour 3 décennies.
Ouais, mais aujourd'hui, on réalise que peut-être les expériences de Vikings n'étaient pas si bien conçues que ça. Mais aussi, il y a de plus en plus de preuves qui s'accumulent comme quoi Mars a connu un épisode aquatique il y a 4 milliards d'années. Et ça, un épisode aquatique, c'est compatible avec la vie. Vraiment, l'espoir renaît. Et puis c'est ici que ça commence, là, dans le désert d'Atacama.
Ouais, avec nous. Allez, on finit?
Oui.
Oh.
U prethodnim misijama nijedan stroj nije uspio probiti ni 10 cm duboko u Marsovo tlo. Sad bi trebalo probušiti mnogo dublje kako bi se došlo do zone u kojoj bi moglo biti tragova života. Cilj je probiti se dublje od metra u slojeve tla na Marsu. Na toj razini nalazi se debeo sloj soli halita. Proteklih godina znanstvenici su otkrili da se život može širiti u koncentriranoj soli, što upućuje na to da bi se život mogao razvijati i u soli na Marsu. Ali kako bi saznali malo više o tome, znanstvenici moraju prokopati po tlu Atakame, sondirati slojeve i otkriti staništa mikroorganizama. Budući da sol treba vodu kako bi se formirala, ekipa znanstvenika iznijela je hipotezu da ako život na Marsu postoji, razvija se, kao i u pustinji Atakami, u obliku podzemnih kolonija mikroba u blizini naslaga soli halita. U srcu pustinje, Marie-Pierre obilazi ekipu koja vadi uzorke tla.
Qu'est-ce que vous faites exactement?
This is a stratigraphic section that covers maybe several million years of history of the Atacama. And there is a layer here that is mostly pure salt. And salt is an indicator of water. And maybe we can also find fossils of microbes or organisms that were living way back then, maybe if there was a lake. So we're done, I think. And we're gonna come out. Okay.
What you're going to find there, what does it tell you about what's going on Mars?
By looking at those rocks, we can learn important insights on where to search for life on Mars. We learned that a specific type of rock preserves better than another type. Maybe the salt layer has better fossils than the layer above it, which has no salt. Then we would go to salty places on Mars. Or maybe it's the opposite, and we would avoid them. So instead of kind of randomly looking for life on Mars, we can be more targeted, more target specific, and search for specific types of rocks and focus on those.
So there are enough similarities between Mars and the Atacama Desert, so you can presume that basically it's the same.
There are a number of similarities in different aspects. Rock composition, it's probably very similar, but it's very important the environment, the dryness, the lack of water, lack of vegetation, for example. And therefore we can see at the microbe-only environment, like Mars.
So if I want to go down there and not contaminate what's there, I have to put that suit, right?
Suit on, yes. There's 2 reasons we do this. The first is because there's very little organic matter in the soil to begin with. And the second is because humans are so dirty. There's bacteria on your skin, you have your own DNA, and you don't want any of that material to fall into your sample. So when we go to look for biomarkers, we want to make sure all of our human dirtiness is contained inside the suit.
Okay, so let's contain my dirtiness.
Let's contain your dirtiness.
Okay.
Okay?
Okay.
Last pair of gloves. So now, because you're touching your body, your hair with the first pair, they're
Okay.
dirty. So the second pair, clean. Yeah.
Wow.
Now we are ready to go. So this hole was dug about 10 years ago by NASA scientists, and this year we came back with NASA, and we dug a whole nother meter, so now the whole hole is about 3 meters down. Okay?
Okay. So, in fact, I'm going down millions of years, right?
Yes, this whole sequence is actually about 6 million years old. So you're looking at clay layers that have never seen the sun for 6 million years.
Wow.
Yeah.
So approximately how old are the different
Layers. Basically what you're seeing here is the accumulation of different types of particles that have been blown in by the wind and deposited over the last 2 million years while the Atacama was extremely hyperarid. But then you get to this layer and you see a very different transition, a very well cemented halite, so table salt actually. And then below you see the particles have been sorted. They're very, very fine. There was a very calm water body that was once in the Atacama. And then my job is to look for the organics or biomarkers that have been preserved in this rock. And the most amazing thing to me, there's little tiny parts of plants. This is incredible. These are roots that are over 2 million years old that are still preserved. You can still see with your eye. This is very unusual.
Wow.
And the reason that we see them is because the Atacama is so dry. Organics that made up that original organism did not degrade in the absence of water. So we think this is very promising for looking for life on Mars. We could find the remnants of a microbial population.
Wow.
Temperatura se penje na gotovo 45 Celzijevih stupnjeva. Prašina i zaštitni kombinezoni znanstvenicima jako otežavaju život.
You heard normal is entre 60 y 80. Tienes 98, 99, 100 y recién tenía 114. Y la presión la tienes en 15,9.
Ah. J'ai le cœur qui bat trop vite.
Sí. ¿Y te sientes bien?
No.
Sí. Yo creo que está deshidratada. Sí, que tu presión está mala. Mira,
¿Podemos beber?
mira la frecuencia
beber?
cardíaca, tiene 120. ¿Sí? Bueno, tiene 120.
¿Puedo beber? ¿Puedo beber?
A ver,
Quisiera beber.
afuera, la lengua.
La lengua, sí, está media deshidratada. Te podríamos poner un suero para hidratarte, sí. Pero tu frecuencia cardíaca está muy alta.
Sí.
Y como te comentaba en la entrevista, eventualmente esos son signos que a nosotros nos demuestran que está pasando algo.
Ok.
¿Ya?
Je vais me reposer.
¿Alguna enfermedad? ¿Tiene alguna enfermedad?
No.
Ok.
C'est tellement extrême ici, vous avez installé carrément un hôpital de campagne. Quel genre de problème est-ce que vous rencontrez?
Bueno, principalmente por el clima tan caluroso, podemos encontrarnos con deshidratación, principalmente que eso se va a notar por taquicardia, frecuencia cardíaca alta, y principalmente también como están trabajando con tantas herramientas, pueden haber lesiones de mano por abrasión y de hecho hemos tenido varias heridas y consultas por mareo, principalmente.
Les scientifiques ici travaillent très dur sur le terrain, creusent des trous. Ils sont très souvent, très longtemps sous le soleil par 40 degrés. Est-ce que vous les surveillez?
Y la verdad que van en condiciones bastante extremas, aunque van cuidados con tomando líquido, agua. Nosotros esperamos que se vayan y alrededor de 2 horas un equipo médico de Fortrek toma una camioneta y se va al lugar donde están trabajando y observamos, les preguntamos cómo se sienten, cargamos líquidos, vamos con material de acá, con herramientas y con equipos médicos para controlar si eventualmente hubiera un problema.
10 kilometara dalje na drugoj lokaciji tišinu pustinje remeti buka. Emilije s drugom ekipom, inženjerima. S njima je dok obavljaju prva ispitivanja buduće bušilice. Ovdje, isto kao i na Marsu, najveći izazov bit će dubina bušenja. Trebali bi bušiti na 10 puta većoj dubini nego što su uspjele dosadašnje bušilice poslane na Mars. Kucnuo je čas da se suoče s terenom.
Now we're getting a little bit of that gear friction.
Manevar su već nebrojeno puta izveli u laboratoriju, ali tlo pruža otpor. Čini se da je stroj dosegnuo svoje granice. Ne sluti na dobro.
Stop. I think we messed up the thread. Do you think the thread has seized? Yeah. What I think has happened possibly is the entire platform has shifted slightly, maybe a centimeter or a few millimeters to one side, which is causing a bowing or a bending in the overall drill string, which is also why we hear the squealing when it goes to that hard layer.
Naslaga soli bila je pretvrda za svrdlo bušilice. Sada treba prilagoditi proračune i znati pretvoriti neuspjeh u uspjeh. Upravo zbog toga su svi ovi ljudi prevalili dug put do ovde.
So you're working on an arm and a drill that might one day be installed on Icebreaker Life. Could you tell us more about this mission?
Well, Icebreaker Life would be part of a new generation of missions that instead of looking for organics or looking for water or things necessary for there to be life, would be looking for life itself, or at least things that would look like terrestrial life. Now, if it's some other form of life that is completely alien to us, then maybe we won't find it. But even then, we'll look the best we can. On Mars, it's very, it's irradiated, it's very hostile on the surface. If we look down below the surface, just as in the Atacama, we can find microbial communities, and we can hopefully find whatever might be living there or lived there in the past. So we need to drill. So Icebreaker, if it flies, would have a drill. And we will bring together the pieces, a rover, a drill, a means of taking the sample and putting it into instruments, life detection instruments that could be a model, or it could be sort of a working prototype for what a life detection rover might be in the mid-2020s.
But the other thing we try to do is having...
We have one of you talented ladies do this job?
Yeah.
All right, so what I'm going to do when he says it's okay is I'm going to just turn this on, and then all you do is you push this button until I tell you to let go.
And we're doing that in order to put the samples in the box?
Yes. This is the wet chemistry laboratory. So these are two of the instruments that are on a mission we're working on called Icebreaker.
I see.
It's very rough, under development. It needs work, but the concept I think is pretty good.
You need it to be autonomous on Mars, right? So it needs to know
everything needs to be autonomous on Mars.
Yeah.
Press the green button.
And press it. Yay! It's like it's stored out the big chunkles from the small ones.
Inženjeri moraju osmisliti stroj koji bi mogao uzimati uzorke. Robot će morati sam obavljati pokuse kojima se ovdje u pustinji bave ovi znanstvenici. Nemaju puno vremena da postignu cilj i dokažu da je njihov rover funkcionalan. Ali samo pod tim uvjetom rover će se moći uključiti u svemirsku misiju. Znanstvenici i inženjeri učinkovitost svojih odluka moraju dokazati na terenu, a svaki instrument koji će biti na konačnom roveru još je u fazi prototipa. Zato treba ponavljati operacije nebrojeno puta u svakojakim uvjetima, kako bi bili sigurni da će biti pouzdani u ključnom trenutku. A za to vrijeme u baznom logoru u jednom hangaru instaliran je improvizirani laboratorij. Ekipa španjolskih istraživača napravila instrument za detektiranje znakova života. Iz pustinskog tla izvodili su prve uzorke koji obećavaju i sad nestrpljivo čekaju rezultate. Trebali su osmisliti mobilan laboratorij koji će biti dovoljno kompaktan da se može ukrcati u letjelicu koja će ići na Mars. Kad uzme uzorke, takav laboratorij moći će potpuno autonomno provesti analizu na površini Marsa i poslati rezultate ravno u bazu.
Est-ce que vous pouvez me montrer et est-ce qu'on peut découvrir s'il y a des traces de vie dans ce qu'on a creusé?
Yeah, well, the way that our instrument works is loaded with a biosensor. You know, a biosensor is a device that has some specific biological components that make react with the sample that you add and gives you a signal. We have a collection here of more than 200 antibodies that we have produced against molecules or microbes that we think that they might be on Mars. So we have produced antibodies against these molecules or these microbes, and we put all together here in our small chip, allow them to react with the sample we extract from the soil. In the case of a mission to Mars, we will receive an image like this. And here what we do is just to analyze. And one way is to analyze this by putting a grid on top of all the places where we put the antibodies.
Et est-ce qu'il y a une raison pour laquelle il y en a qui sont beaucoup plus rouges que d'autres ou ça n'a rien à voir?
Yeah, the higher the intensity, the higher the concentration of this microbe, of this molecule in the sample we have analyzed.
So these are the compounds that tell you there were bacteria here.
Right, that's the part.
Okay, so if someday we receive an image like this from Mars, you'll be sort of happy?
Yes, for sure.
Neki znanstvenici smatraju da smo otkrili život na Marsu zahvaljujući misiji Viking, ali nismo znali interpretirati rezultate.
So it's been a long time that you guys are searching for life on Mars. Don't you think that if it existed, you already have found it?
Well, I would say that it's been a long time that we've been thinking about how to search for life on Mars, but there's really only been one mission that searched for it, and that was Viking 30, 40 years ago. So one mission for the whole planet, the chances of not finding it are pretty high.
And just think about Viking landed on Mars in 1976. Think about how much technology has advanced since then. We're talking 1970 technology to search for life and 1970 level understanding of what to look for or how life might behave.
What lessons have been learned since Viking?
Viking was searching for life using a very specific approach. Now, these incubation experiments assume that, one, the microbes are active or capable of activity, they're not dead, and two, that we know what makes them tick, what they like. So we assume that by giving them water, raising the temperature, and giving them food, they will wake up and say hello. And those are two big assumptions that we cannot make again, because we know that there could be microbes in the soil and they could be dead, and we could continue giving them food and they would never say hello, they would stay dead. So in fact, if you do the Viking experiments in the Atacama, it's very likely you get the same Viking results on Mars.
Absolutely.
And we know that there are microbes here, but we know that many of them are dead and many of them don't like what we give them in order to activate them.
Well, one thing I think we've learned is that when we send the same kind of instrument, we get the same answer. But every time we send a different kind of instrument, we learn something new.
What would be the biggest challenge when you want to detect life or traces of life on Mars?
Well, scientifically speaking, technology aside and economy aside and everything aside, the most difficult thing is that we don't really know what we're looking for. But we might be making the mistake of assuming that what's common on Earth might be also common on Mars. And if we focus, for example, on something that is very common on Earth but never evolved on Mars, we might actually miss Martians. DNA is a very good example. Every organism on Earth has DNA in it. It's a universal biomolecule on Earth. We could search for DNA on Mars, but what if life on Mars didn't have DNA? What if it had something different? We might miss something that's completely unique to Mars.
Budući da iz rezultata zadnje misije na Mars znanstvenici nisu mogli izvući jednoglasne zaključke o tome kako da ih interpretiraju, sada treba osmisliti misiju koja će sigurno i bez ikakve dvojbe detektirati život na Marsu. Upravo taj izazov postavili su si znanstvenici i inženjeri koji rade u pustinji Atacami. Nekoliko kilometara dalje testira se još jedna komponenta konačnog vozila. Emily je s Michaelom Furlongom, kanadskim znanstvenikom koji se specijalizirao za robotiku. Danas na teren izvozi svoju najnoviju kreaciju. Ovaj prototip u koji je ugrađena umjetna inteligencija vjerojatno je jedna od ključnih komponenata za uspjeh misije.
Now, I'm going to mount the sensor head.
Oh, okay.
Which is the payload that we're interested in collecting data with. So it's got 2 gigabit Ethernet cameras.
Donc ça, c'est 2 caméras panoramiques?
Yep, actually for stereo vision. So like human eyes, we use these to measure distances to the terrain and to get what the elevation looks like in front of the vehicle.
So you're testing a system that has to be autonomous and has to manage itself in the terrain.
Now, really what we don't want is the scientists to be making decisions like drive here, drive there, avoid that obstacle. We want them to be able to say, these are the science things we care about. These are the rocks, the minerals, the patterns in the terrain that we want to go investigate. And we don't want them to have to think about how to drive the rover. We want the rover to do that for them.
What kind of constraints and obstacles do you have to take care of in order for it to manage itself?
The single biggest problem is uncertainty in perception, in that what the robot sees on the ground in terms of if there's a hazard there, is there a ditch, or is there a bump, or is it flat, is it safe to drive on, is it sandy, are you going to get stuck? And being able to identify different problems. But what I actually think is most challenging are these halite fields here, because a lot of the color is very much the same, so it's not necessarily easy to distinguish what the shape is like.
Où est-ce qu'on va?
We're going to go out that way. We're going to drive along the ridge to see if we can observe the change in elevation. Then loop back around and then drive through some of these, the halite nodules.
Donc on a du chemin à faire quand même là.
Right.
Je peux conduire?
Yeah.
Ok. Je peux aller vite?
Yeah, you can go as fast as you like.
So what's going on if the cart can go over rock?
Generally, what depends on the size of the rock. What I do is collect the data by stopping at the rock, backing up, and then sort of just driving around it from all sides. That way we get more views about the rock. We now have a nice model we can manipulate and plan with, and then teach the rover what to do with it when it sees things like that. Okay.
So right now, basically, we're living the first steps of a preparation for live detection mission on Mars.
Yeah, that's the idea. So yeah, this device, the drill, the work being done by the scientists, this is all preparation and steps for testing out the idea, improving the idea of sending these instruments to Mars to seek out evidence of what life may be there.
Ako u tlu na Marsu ima tragova života, što možemo očekivati? Koji oblici života mogu odoljeti tamošnjim surovim uvjetima? Samo iznimni mikroorganizmi, koje zovemo ekstremofili, sposobni su za život u ekstremnim uvjetima, što je u ovom slučaju vrlo suh i slan okoliš. Jocelyn Di Ruggiero i njezin suradnik Diego zajedno pretražuju svakakva mjesta u potrazi za takvim mikroorganizmima. Žele shvatiti kako žive i preživljavaju u tim ekstremnim uvjetima, te kako uspijevaju funkcionirati.
Alors en fait, l'une des manifestations de la colonisation, c'est ces zones vertes qu'on voit ici. C'est un pigment qui s'appelle skytonamine. C'est une zone qui est très légère, vert pâle, où les micro-organismes sont encore actifs. Elles sont vertes parce que c'est des micro-organismes qui font de la photosynthèse.
Est-ce que c'est ce genre de microbes qu'on appelle extrémophiles?
Oui. Et donc ces extrémophiles poussent aux extrêmes de salinité.
Mais comment ces extrémophiles-là ont pu s'adapter? Est-ce qu'ils ont une stratégie particulière? Parce que le sel, a priori, c'est pas hyper compatible avec ce qu'on imagine de la vie.
Ouais, le sel, c'est pas compatible du tout. Et en fait, pendant des centaines d'années, les gens ont utilisé le sel pour préserver les aliments. On a de la viande qui est salée, du poisson qui est salé. Et l'effet du sel, c'est de déshydrater les micro-organismes. Mm-hmm. Et alors, en fait, ces micro-organismes ont des adaptations qui leur permettent de résister à la déshydratation par le sel. Et ce qu'ils font, ils accumulent du sel à l'intérieur de leurs cellules, dans la même quantité que ce qu'il y a à l'extérieur. Donc en fait, l'eau n'est pas retirée de leurs cellules et ils peuvent survivre.
Mais il y a d'autres extrémophiles qui se sont adaptés à des conditions différentes, mais très extrêmes aussi.
Mm-hmm. Donc il y a des extrémophiles au niveau de la température, donc extrême de température, très chaud, très froid, des extrémophiles adaptés aux conditions de pH, donc très acide ou très basique, pression élevée par exemple.
Est-ce qu'on peut espérer trouver ce genre de micro-organismes-là sur Mars?
En étudiant les micro-organismes sur notre planète, dans ces environnements, on peut arriver à estimer quels sont les endroits où on pourra les trouver sur Mars et quels sont le genre de molécules qu'on va pouvoir découvrir. Donc je pense que maintenant, il n'y en a peut-être pas, mais il devait certainement en avoir quand Mars était un petit peu plus humide.
Sve prikupljene informacije bit će korisne i za članove drugih ekipa koji izrađuju instrumente za detektiranje života. Ako život na Marsu postoji, moći će točnije naciljati gdje da ga traže.
Magnifique. On se met là pour observer?
Ouais.
Bien.
Ça fait quand même longtemps qu'on cherche de la vie sur Mars. Et puis on a beaucoup progressé depuis l'époque où on s'attendait à trouver peut-être une civilisation entière. Parce qu'on avait observé vers la fin du 19e siècle ce qu'on pensait être des canaux d'irrigation. Aujourd'hui, on a réduit nos ambitions, on cherche de la vie microscopique ou encore des traces de vie qui auraient existé il y a très 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 longtemps.
Planet Mars naš je blizak susjed, ali od Sunca je udaljeniji od Zemlje. Otprilike je od nje upola manji, ali je jednako star, ima 4,5 milijarde godina. Prosječna temperatura na površini iznosi minus 60 Celzijevih stupnjeva, a gravitacija je trostruko slabija nego na Zemlji. Zovemo ga crvenim planetom zbog velike količine željezova oksida na površini.
Oui, parce qu'on pense qu'il y a 4 milliards d'années, le climat de Mars était beaucoup plus propice à la vie. On pense qu'elle était couverte d'eau, on pense qu'il y avait sur la planète Mars des cascades, des rivières, voire un gigantesque océan.
Tout ça a vraiment mal tourné.
Oui, ça a mal tourné parce que la planète elle a perdu son atmosphère protectrice. Du coup, tous ces océans, toute son eau s'est évaporée.
Aujourd'hui, là, on irait sur Mars, ce serait vraiment pas une promenade très, très, très agréable. Hein? On aurait froid, on gèlerait même.
Oui, ceci dit, il faut quand même souligner qu'une partie de l'eau de Mars a subsisté sous forme de glace, en souterrain et dans les calottes. C'est pas du tout une planète morte.
C'est tout le contraire de Vénus, finalement. Puis pourtant, Vénus, c'est aussi notre voisine. Mais elle, vraiment, parce qu'elle est proche du Soleil, les océans se sont évaporés, puis ont tellement épaissi l'atmosphère que là, c'est l'enfer. C'est un effet de serre épouvantable. Il fait quelque chose comme 460 degrés sur Vénus.
Tu vois, il a beau faire 460 degrés. Les chercheurs excluent pas du tout la possibilité que la vie ait pu subsister. Par exemple, dans les nuages de la haute atmosphère. La vie est forte.
Kako bi naciljali područja koja bi mogla skrivati tragove života na Marsu, treba i dalje bušiti i čitati tragove u tlu pustinje Atakame. Prvi rezultati ohrabruju. Analize uzoraka znanstvenicima su donijele dragocjene informacije, ali ne dolazi u obzir da sada stanu. Pokus moraju ponoviti na drugim mjestima kako bi potvrdili podatke. I to je svakodnevica ovih znanstvenika koji su ušli u natjecanje.
Hello? Hello? You're still digging a hole?
We're still digging. We can't get enough digging. Well, you know, if you want to get to the interesting answers, you need to work hard.
Why do you need to dig another hole?
For a number of reasons. One is we want to access fresh material that hasn't been exposed to the environment for decades or many years. The other one is because we want to get a comparison. We want to get 2 data points instead of 1. There are certain things in the first hole we studied that are a mystery, and we think that without a second hole, or maybe even a third hole, we won't be able to solve that mystery.
those rocks are pretty hard. Is there a particular procedure? How do you dig?
They're harder than what we were expecting. We have to combine heavy machinery, so to speak, a drill with a chisel, and go slowly breaking it down, one-person job. We have to take shifts so that not one person has to do all the work and eventually collapse.
I imagine that you wouldn't say no to a helpful hand.
Of course, we can use all the help we can get.
Should I practice here first,
if
or
you like.
I'm good to go?
Yeah, I think you're good to go.
Okay, if you think so.
So just grab it like this. Yep.
Okay. Anywhere?
Anywhere.
Okay.
The harder, the better.
Okay.
Stress relief.
Exactly.
Et si vous aviez la chance d'aller sur Mars faire exactement la même chose, ce serait le même genre de terrain que vous chercheriez, puis vous feriez exactement les mêmes manipulations?
It's not different from here with respect to what we would do on Mars. On Mars, it will be more complicated because we will be wearing bulky suits on top of these heavy machines.
Et avez-vous bon espoir qu'un jour des astronautes vont avoir la chance de le faire?
Well, I hope so, because these can be done by a robot, but it would take a long time and a lot of money. And these same hole, maybe a robot, it would take a month or a year or several years. And so humans can do a lot faster, a lot better. And hopefully one day we can have humans doing the same kind of science in the field on Mars as we do here in the Atacama.
Marybeth, tu as trouvé des traces d'eau très anciennes dans le trou, mais tu as aussi trouvé ce qui pourrait être des traces d'eau pas du tout anciennes sur Mars.
What we've discovered on Mars is a sign of more recent water. And that's really exciting because we know that water is an essential ingredient for all of life. So the fact that it might be occurring today near the surface is really exciting for astrobiology.
Mais est-ce que ce serait quand même possible qu'il y ait de l'eau liquide qui coule sur Mars?
We're seeing something that suggests that there is water in the near surface. It was quite exciting to find this hydrated salt because I'm very passionate about finding life on Mars, and I think that having confirmation of an essential ingredient for life so close to the near surface is a step towards assessing the current habitability of the Martian surface.
Penses-tu que tu pourrais faire d'autres découvertes aussi importantes dans les années à venir ou dans les décennies à venir?
We don't know exactly where the source of the water is. This is still a big mystery. Maybe it comes from the atmosphere, maybe it's the subsurface. So there are scientists who are working on this problem right now, but we may discover, once we discover the source of water, that'll be another step towards solving this puzzle.
Ekipa inženjera koju predvodi Brian smjestila se na novu lokaciju. Nakon što su došli do prve naslage soli, koja je bila kobna za prvi test bušenja, sada treba nekako probiti. Ako uspiju probušiti prag od 1 metra u pustinji Atakami, to će biti dokaz da ovaj stroj može bušiti na toj dubini i na Marsu.
Retract by 10 centimeters.
I would not want to go back. Let's get all the way through the halite layer first.
Stroj je rekalibriran i svi znaju koji su ulozi. Brian je za upravljačem. Bušilica napreduje.
Increase the limits then. These motors can handle it. On our way to...
Inženjeri su zadovoljni učinkom stroja, što im uljeva optimizam za nastavak priprema za misiju.
Actually, if it's at 150, let's stop now.
Cilj je postignut. Vrh bušilice zaustavio se na više od 1,5 metra dubine, daleko iznad očekivanja. Sad će Emily uzeti uzorke. Njima će se testirati mobilni laboratorij ekipe Viktora Paroa.
So are you ready to take samples?
Catherine Bywaters znanstvenica je u NASIN-u laboratoriju. Ona mora skupiti uzorke prikupljene bušilicom i usporediti ih s onima koje je ručno izvadila ekipa Alfonsa Davile.
And then rub together. Okay. So this is just to kill any microbes that you might have on there. And now go ahead and scrape off the sample.
Comme ça?
Okay.
Perfect.
En fait, il faut gratter tout ce qu'il y a sur le côté et qui est collé.
How far have you drilled?
So right now we're at 160 centimeters, and we're going to go to 185. That was our goal, so we've reached our goal.
Super. Mission accomplie.
Yes. So we're going to put your sample from here into here.
Okay.
Is that what she's like?
And then just touch.
Just touch it. Okay. Like that, huh?
Et ben voilà.
Et ben voilà. Merci Catherine. Merci beaucoup.
May I ask you a question?
Sure.
Do you believe that we'll find life outside of this planet?
Of course, I do. I trust you guys. I am confident in you.
Preskočivši novu letvicu koja je bila postavljena na 1,5 metra dubine, misija Icebreaker Life napreduje. Svi se nadaju da će NASA prepoznati vrijednost ostvarenih rezultata i relevantnost metoda kojima ovi znanstvenici žele tražiti dokaze života.
Admettons qu'on parvienne à totalement écarter la possibilité d'une contamination par les humains. Si on trouve la vie sur Mars un jour, est-ce qu'on pourra dire qu'elle a émergé sur Mars?
There is basically two possibilities for the origin of that form of life. The first case, we call that a second genesis. That would be an Earth genesis of life, a second genesis of life on Mars. That would be the best case scenario for an astrobiologist, because that would be a second example of how life can originate and evolve independently. Because if it happens twice in the same solar system, it might happen everywhere, all the time. But we cannot discard the possibility that life, if we find it on Mars, came from a different place like the Earth. That process, which is called panspermia, we know that could happen because Mars and the Earth, somehow they've been exchanging spit. And we know that those rocks can carry organic compounds. But some research shows that an organism could in fact survive the transit from Mars to Earth or the other way. And so we cannot discard this possibility, and until we find evidence of life on Mars, we will not be able to tell whether it was a second genesis or they are our close relatives.
Donc en fait, s'il est possible que la vie ait émergé sur la Terre et qu'elle ait ensemencé Mars, l'inverse est vrai aussi. C'est possible que la vie soit née sur Mars, qu'elle ait ensemencé la Terre.
Because in our solar system, the sun is the big gravitational well. Everything goes towards the sun. So it's easier to eject the rock from Mars that comes towards the Earth, which is close to the sun, than to eject the rock from the Earth and travel all the way out to Mars. And some research suggests that an origin of life was more likely in early Mars than in early Earth. Because we know that Mars is a smaller planet, and so the surface cooled down faster. Small bodies cool down faster than big bodies. And so conditions for the origin of life maybe arose earlier on Mars than on Earth, maybe by millions of years. So there is a possibility that life, actually, we are all Martians, and we came to this planet just after the origin of life on Mars.
I na kraju, nakon svih teškoća, možemo reći da je ova misija bila vrlo uspješna. Svaka ekipa postigla je i više od zadanih ciljeva. Bušilica je uspjela prijeći zapreke koje je postavilo tlo pustinje Atakame. Ekipa kopača potvrdila je koje su najbolje zone za detekciju tragova života, a umjetna inteligencija u roveru počela je učiti. U trenutku kada treba napustiti pustinju Atakamu, ekipa je vesela i zadovoljna zbog dobro obavljenog posla. Svi odlaze s nadom da će možda baš oni napisati novu stranicu u knjizi o traganju za životom na Marsu.
Tu te rends compte? On a testé des instruments qui seront peut-être un jour installés sur des missions martiennes. Oui, je me rends compte. Je veux dire, on a collecté des échantillons avec un bras articulé. On s'est battu contre de la roche coriace. Moi, j'ai même fait rouler un prototype de rover. Oui, puis on a trouvé des colonies de micro-organismes super bien cachés. J'ai envie de dire que d'une certaine manière, on a été sur Mars.
Oui, ou en tout cas, on a eu accès aux coulisses de la nouvelle conquête de la vie sur Mars. Il va y avoir la mission Icebreaker Life vers 2025 qui va embarquer une foreuse comme celle qu'on a testée. Puis avant ça, il y a aussi ExoMars, la mission européenne complètement dédiée à la recherche de la vie.
Ouais, puis ce qui est super, c'est que depuis Viking, grâce à des missions de terrain comme celle qu'on vient de vivre, on sait beaucoup mieux où et comment chercher la vie sur Mars. Donc on a le droit de penser que si la vie existe sur Mars, ces missions-là de futures générations, elles vont la trouver.
La vie existe sur Mars.
Tu penses qu'elle existe?
Je veux tellement qu'elle existe.